Hello, Mr. Aaron, Mr. Rana, right? Yeah, good, okay. So we are given n teams. Numbers from 0 to n minus 1, okay? And these n teams compete in a tournament, okay? In a tournament. So we also given a metric to represent if one team is stronger than another one, a metric. So for example, if we given two teams, right? So the two teams, the index is 0 and 1. So if we given this index, okay, so a metric, this is basically a graph, right? One way to represent the graph. So for example, like if the 0 is stronger than 1, okay? 0 is
Why
stronger
is
than
0
1.
stronger than 1?
No, I'm just giving an example. Team 0 is stronger than team 1. Then
what's the point of having the competitions? Then what's the point?
That's right. Just two teams.
What's the point of doing it when you know who's gonna win?
No, I'm just giving you. So the question is that to find out who is champion. So a champion is the team that is stronger than the rest of the teams.
No. It's not like champagne, like
Champion.
Champagne is like alcohol, it's not a
you
drug.
literally said champagne, not champagne.
Okay, so champion. Okay, champion.
Not champagne.
Champion. Okay. If a team is stronger than the rest, right? There are n teams, for example. If the team is stronger than the n minus 1 teams, it's the champion. Okay, champion. For example, in this case, we know team 0 is stronger than team 1, so we know team 0 is the champion because it's stronger than the.
3 zeros.
So that's very good. Okay, so now let me expand this. This is one of the way to represent a graph. This graph, right? This is basically a directed graph with a directed graph. For example, like if this is Gij, if it's 1, it means that we have an edge from I to J. Okay? If it's 0, then we don't have any edge from I to J. So for example, G 0 0 0 1, right? Row 0, column 1, which is this one, is 1. So it means that from 0 to 1 there's an edge. That's a directed graph. Okay? Then there's only one edge, so that means that team 0 is better than 1. Okay, so for example, this is called adjacent metric. We talk about that. That's the one of the way to represent a graph. Another way, so how do we represent using adjacent list? It's very simple. So it's just basically a dictionary, right? 0 is pointing to 1. That's it. Okay, if it's an integer, we don't need to have the code here. Okay, that's it. Look, 0 is 1. This is a simple graph. Okay, let's take a look at a more complex graph. For example, like 0 to 1, 1 to 2. Okay, and then that's it. And 0 to 2, for example. Okay, so obviously this one, who's champion? 0, yes. 0 is stronger than 2. 0 is stronger than 1, right? So 0 is the champion.
The smallest number.
No, not necessarily. I'm just giving an example. For example, if I can relabel it for 2, 0, then in this case, 2 is the champion. Okay? You are given this graph. Okay? For example, if the edge from 2 to 1.
But I thought you given a mattress.
Yeah, this graph, we can represent this graph using the metric. It's the same thing.
It doesn't look the same.
Okay, so we are given this. How can we represent using the metric? Okay, so there are 3 edges, right? 0, 1, 2.
It might be like...
Okay, so there are values here, right? There are 9 values. Initially, they are all 0, and then we're going to replace it because there are 3 nodes, right? 3 nodes. This is G. Okay, there's an edge from 1 to 0. So it's G1, 0. G1, 0 here. So we need to put this 1. There's an edge from 2 to 1. So it's G2, 1, right? G2, 1. What's G2, 1? Where is G2, 1? 0, 1, 2, right? 2, 1 here. So this is 1. Okay? And then there's an edge from 2 to 0. So G2, 0. Which value is G2, 0? Yeah. 0, 1, 2, right? 0. Okay? So this is 1. So look, this is the metric. It's equivalent.
Yeah, but
There are 3 nodes. So we have a 3 times 3 metric.
It looks more confusing. I think that one is more easier to use.
Yeah, you're right. Okay. So this is a square metric, n times n. So at the beginning, we fill all the element in the matrix 0. And if there's an edge from node I to node j, then we change this to 1. Okay. So if it's a weighted graph, right? Remember the weighted graph. Now it's unweighted graph.
I don't think a match is a very good example because, for example, you never know. So when it's not like okay, if one wins against 0 and 2 is winning against 1, then it doesn't really mean 2.
You find a problem, right? For example, if 2 wins 1, 1 wins 0, but 0 wins 2, then there's no champion, right? Yeah? Champion, yeah?
Champion.
And it doesn't.
No, but it doesn't really work that way.
If it's 0, it can be a 2 and
For
a 2 can be.
example,
Just for simplicity, we are given a graph which we always can find a team which is stronger than the rest. We always given a champion.
Yeah.
There's no contradictory results.
But it could be like a coincidence, like one team wins against another, like 0 wins against 2. Yes, this is more like who's the heaviest person.
Okay. So for example, like this is not allowed in this graph. This is not what we are given. Okay, 0 is bigger than 1. I mean, stronger than team 1. 1 is stronger than team 2. And 2 is stronger than team 0. It's a cycle, so there is no champion. Okay. Champion. Okay. So we are not given this kind of graph. Okay.
Yeah, but then that's not really a match, sort of like. That's just more like a boring one because it's more like who's the tallest or heaviest person.
Okay.
Right.
Yeah, because this we are given this graph, we want to make it simplified. So we're given a graph which we can always find a team, one team that is stronger than the remaining teams. Okay. So in this case, we don't have cycles here. We don't have cycle. It's okay. So what are we saying? It's unweighted directed graph. Okay. Look, if we replace the 0 with any other values, then that's a weighted, right? For example, 2 to 1, the cost is 3. Then instead of putting 1, we put a 3. Okay. But this is unweighted graph.
But I think the matrix is harder to use, and I don't think you can really use it anyway.
But we are given this, so we can, based on this metric, we know.
I thought you said you were given that.
That's the graph, but that's the way to represent a graph using the data structure matrix.
But you're not being given it. It's just
Okay.
So what's the computer given? Is
Like
that one?
this one.
That one's ring.
This is for us humans. This is drawing, but computer needs to understand this way. Computer graphs.
Yeah.
This is the data structure. The computer adjacent
But how do you even use that?
adjacent metric. Okay. And then another way, as I said,
Yeah,
adjacent
how do you
list
use it?
is the dictionary. Key is the node. The value is the list of the nodes that this key points to. Okay, so for example, if we represent this graph using this adjacent list, how can we represent it? We can use it this way, right? So 0, this is a dictionary. Key, this is a key. 0, 1, 2. 0 points to nothing, so it's an empty list. 1 points to 0. Okay, and 2 points to 0 and 1. Okay, yeah. Okay, so this is another way to represent this same graph using the key value pairs, key value dictionary. Key is the node, value is the list of nodes it points to. Okay, and if this is a weighted graph, like this is value 3, for example, 2 points to 1. So instead of 1, we can have another dictionary here, which is 3. Okay.
Why another one? The one isn't pointed to 3.
1 is 2 points to 1 with the cost 3. So 1. No, this is another dictionary. Key value pair.
Yeah, but there's already on the second row. There's a 1. So why isn't it there? And I don't get the point of a 3 as 1 isn't pointed to 3.
This is not the This is the weight. Cost. Okay.
Cost of what?
For example, the cost from no 2 to no 1.
Why do you need the cost to actually win a match?
No, okay, not related to this question, okay? So I'm just saying the graph problem in general. Like for example, the city, the travel, right?
I thought you said that we're not related to the match, like the teams a match problem. But then you started talking about, imagine like, you know, when you travel.
Okay.
And then you started talking about that when you said that you won't do really.
Okay. Anyway, so
Anyway.
any idea how can we solve this?
So looking at that thing, you just look at
So how can we find out who is the strongest than the rest? So how many ways can we do that?
you go to the bottom left corner and then you look at what row is it on and then you return that.
Why is the left corner? No, it could be different, right? So how can we find out that?
What do you mean it could be different?
This is just an example. It's not always like that, okay? So I mean,
I know, but
so what are we looking for here? You know, what are we looking for?
For the team which has one. So there's 3.
Yeah.
And let's
So
just call it whatever. And so it's 2. The champion must win from whatever subtract 1, right?
yes. Do you notice what's the difference between this node to all these 2 nodes?
Okay.
This
2
node.
has 1 against 2,
Okay.
and 1 has 1 against 1, and 0 has.
Okay, so okay, so 2. What's the difference between 2 and other nodes in terms of the edges?
They don't have. They haven't won all of their matches.
That's right. This 2 doesn't have incoming edges. It has only outgoing edges.
Yeah, but that's basically the same as.
I know. This is a proper term to describe the
Shut
2.
it. Okay.
Stop saying
Alright, shut up your cake on.
Okay.
Interrupting me. So basically, if edges is pointing outwards,
Yes.
then that means they won.
That's right. Yes.
Yeah, but
Okay, this
but
is outgoing.
You're saying that's what it looks like, but you were talking about how computers get that, and so they need to. But there isn't any arrows there. And
That's right. Yes.
I know. That's my point. And you're saying talking about the edges when it could have been like winning because like. So basically, if all of the edges is outward, that means they won all of their matches.
We're done.
Yeah.
Okay.
So you're basically saying, it's basically saying, like, for an answer, like, it's basically saying, like, you asked me what does another synonym for big mean? And I said, huge, and then you said, no, it's giant.
Okay. Yeah, okay. Let me rephrase this. Yeah, we're looking for the node which does not have any incoming edges. That's called Indegree. The number of edges, right? The number of edges for a node is called the degree, and it can be categorized into 2: incoming degree and outgoing degree, right? For the number of incoming and outgoing edges. Okay. So this one, we are looking for the node which has the 0 Indegree. Okay, so then we can go through this matrix to count the Indegree and then return the 1.
Computers won't see those arrows.
This one, yeah.
But those don't have any arrows, so why are you talking about the arrows?
Arrows, we can go into this matrix. Okay, let me write the code and you'll understand what I meant.
The matrix doesn't even have any arrows, so why are you
We visualize the edges in our imagination.
Yeah, but
if it's 1, it means that...
but that doesn't even help or do anything because the computer still does. It looks like a matrix with no arrows.
Look, we go through, we iterate over the element. If it's 1, we know there's the edges, right? Look, this one.
Yeah.
Okay.
Yeah, but there's no arrows.
Look, this one, which is coordinate is 1, 0. So it means that there's an edge between 1 to 0.
Yeah, but there's no edge. It's just that they won a match. One just won against 0.
An edge means that it wins, it's stronger. Okay?
No, because then they have to be narrow, but there isn't a narrow. It just means that one against 0.
Yes, 1 and 0.
Yeah, but there's no edge.
There's edge. Okay, so let's say...
Yeah, but you keep on talking about edges when there isn't an edge.
It's 1, there's an edge. Okay, do you understand this point? If it's the 1, it means that there's an edge from 1 to 0. Okay?
Yeah, but there isn't an edge. It's just
In your mind, the imaginary edge.
It doesn't matter if it's imaginary or not, because a computer still needs to do the same thing.
Yeah. Okay. Let me write the code.
Whether you imagine it or not.
Okay. Enough. I know you understand. Okay. Don't confuse the audience.
I know. It's just that you keep on saying that. You keep on talking about edges when there isn't any edge.
Okay.
Especially in the mattress.
Okay. So this matrix, yeah, this is called adjacent matrix.
So how do you
It
spell
represents the
mattress?
matrix. Matrix.
I thought you were talking about like the mattress on the bed.
Matrix.
No, I thought you were talking about the mattress on the bed.
Adjacency. I don't know how to spell that.
Adjacency.
Means the neighboring. Okay. So we given this graph representing in grid, which is the adjacent matrix. If it's 1, it means that there's an edge between I to j. Can you tell me why the adjacent matrix diagonal is always 0, or it's always 0, for example?
That's because
Why?
or the first one, because 0 didn't even win.
What's so special about the coordinates in these diagonals?
Is that 0 doesn't win against 0. And
Yeah. Look at this GII. Okay.
Not.
So node I doesn't have an edge to itself. That's what it basically means. So because it's 0, there is no edge. Okay.
Yeah, but there isn't any edge.
Okay. Define. Let's say find a champion. Find C.
Why are you
Okay.
wearing
G.
those clothes?
Because we have no school uniform data.
So we call this Indegree. Indegree is a default dictionary. Default dictionary. With at the beginning default value is 0. Okay. Then n equals the length g. For I in range n. For j in range n.
I'm strong.
Range I actually. Look, do you notice that if here is 1, this must be 0. If here is 1, this must be 0. It's not symmetric, it's the opposite, okay? Because if if there's an edge pointing from I to j, there will not be an edge from j to I, okay? If there's an edge from node I to node j, so we know for sure there's no edge from j to I, okay? So we just need to go through from j up to I. So we just need to visit half of it, either this half or this half, okay? So then Indegree, if there's an edge from I to j, Indegree j plus equal gij, okay? So this is the same thing as if gij equal 1, then Indegree j, there's an edge from I to j, Indegree j plus equal 1, okay? Otherwise Indegree j plus
it's
equal 1.
always a square.
Yeah, it's a square.
Yeah, it's always a square.
Yeah.
So isn't always a champion is like the bottom left corner?
No,
A hair.
no. I mean, I could give the metric like that. I could give the metric like that. Then it's the opposite, right?
I know it's always like the bottom left or the bottom right, isn't it? Because it's always the one which is like tucked in. You know what I mean? You said talked about the adjacencies.
Yeah.
Like the. Let's not talk about the diagonals. It's just that since adjacencies and the corner has the most adjacencies, which means it's one all of them the most matches. Does that mean is a champion?
I'm not quite sure. Yeah, we'll get back to that, okay? So
You
after
never
that.
do.
Okay, so this one, and then after that, we need to find out which one has the 0 Indegree, right? For I in range n.
Just
If Indegree I is 0, then return I, right? And obviously we can do the next, return next function, next I for I in range n if Indegree equals 0. Okay. Next function, the second parameter specify the default value if there's no next. Okay, but in this case we always given a valid graph.
yeah, the thing will be you just need to find the one since there's only ones and zeros, you just need to find the one which has adjacent, not including the diagonals, the most adjacent to the thingy.
That's right. Yeah.
Yeah, I've been talking about that for like 5 minutes, but you ignored me.
Good. That's very good.
Yes,
So,
that means
okay, let me rephrase. We can find the row which has the n-1 ones, right? Because if there's one row has the n-1 ones, it means that that team wins. First row has 2 ones, so the sum of the ones is 2, and it's great because there are only 3 teams. So if the champion must win 2 teams, so look 1-1, right? We just find out which row.
No, actually this is must be the champion. The
opposite.
Yeah, this one wins against this and this. No, it doesn't win against itself.
Oh, okay, the opposite. Okay, so this one, so we need to find out the ones, the sum of the ones which has the maximum. Okay, actually this is not a valid graph. It's the opposite, so it's this one. Okay, because we are given the I to j, right? Gij equals 1. Okay, Gij equals 1. So we find out that 0, 1, 2, 0, 1, 0, 2. So we just need to find out the row which has the sum of ones equals to n-1. Am I right?
Yeah. But the thing is, it's not really like how if you look at it, because so this row has 2.
Yeah.
And so that means this one must be the champion, right?
It's not a champion.
Yeah, because this is 2-0 and 2 wins against 0, so 2 is the champion. But the thing is, this wins against that and that, right?
This is 1. It means that 2 wins 1, 2 wins 0, 2 wins 1. Yes, so the 2 is the champion. Yes. And here it's also okay.
I thought this one.
No, because this one the coordinate is 2, 0. This one coordinate is 2, 1. So 2 wins 1, 2 wins 1, 2 wins 0. So 2 is the champion. Yes, that's right. So previously this is 0, 1, 1. So it's also okay. 0 wins 1, 0 wins 2. So you see? So we just have to find out the row which has the sum of 0. So it's very simple. Return max range n, right? Range n, and then with the key will be lambda I, and then sum I. Okay? You see, we want to find out the maximum of range n from 0 to n-1, but we want to use the key which is the sum I, sum gi. Okay, sum gi, which means the number of the ones in that row. Okay, make sense?
No edges.
Yeah.
No edges.
What edges? Okay.
Yeah, there is no edges.
Okay, so this is one way. Another way is we use the filter. Okay, we filter out those the rows which has the n-1 row. It's similar. Okay, so we can say g max the next function, the next filter lambda I sum gi equal n-1, and then we given this range function. Okay, this is similar. We have 3 ways. Yeah, one is to find the counter degrees and then find out the vertex, which is the 0 Indegree, because that's the champion. Right? The champion doesn't have any incoming edges. 2 other way, which is that find out the rows which has them n-1 ones, or we filter out the rows which has n-1 1 using the next. These 2 basically the implementation is the same. The time complexity is the O(n). The n is the number of the edges, number of the vertex. Okay. To sum up, we're given n teams.
Excuse me.
Index from 0 to n-1, and we are given these matched results between 2 teams. Okay, so if team A wins team B and team B wins team C, then it's always true that team A wins C. Okay, so we're given this graph. Basically, we're given this graph, directed graph, okay, unweighted directed graph, and we can find the winner, the strongest team among all the n teams. So we talk about 3 solutions. The first one is to compute the integree. Integree is the number of edges, incoming edges to a vertex. So we find out the integree for each vertex, and then the winner, the strongest team, will be the vertex with 0 integree. Each outegree means the A, vertex A wins vertex B. If vertex B is the loser here, so it will have 1 incoming edges, okay? So we can count this the number of the we can count the number of the incoming edges, which is the integree. So we use the dictionary to store the number of the edges for that vertex, for each vertex, and then we go through this grid, which is the adjacent matrix, to count the integree. Yeah, this is Gij, means that if Gij equals 1, then there's an edge from I to j, then we need to increase the integree j by 1, and at the end we go through each vertex n and then try to find out which one has the integree 0. So this bit can be simplified using the next. Return next bracket I for I in range n if integree I equals 0. Okay, the next function, the second parameter, is the value to default value when there's nothing in the first parameter, which is the iterator or a list. So the second and third method basically the same thing. Okay, so the winner, the strongest team, must have 1 n-1 matches, right? So the champion, right? The champion. Okay, the champion must win. Champion must win n-1 team. The second method is that we count the number of ones per row, and if it equals n-1, it means that that team wins n-1. So it must be the winner, the strongest team, the champion. Okay. Alternatively, we can use the filter function. Filter, the first parameter is the lambda function. It's a function specify what criteria to filter out. So we specify the lambda I sum I equals the length, right? Sum gi equals the length, and the second parameter is the list. Is the data which we want to filter out. Then we filter out that, and we use the next function to return the first matched criteria, which is the winner. Okay, so look at this one. Max range. This is the second method, right? The max return the max range n, and we're given a key to find out. This key basically says how do you find out the max function, and we're given a key now, which is the lambda function, lambda I sum gi. Okay, gi. So basically we are saying that which row is the maximum, contains the maximum ones, sum gi. Okay, the time and space complexity is O(n) because we have n vertex here. We need to store the integree here. We need to go through each vertex, right? Actually, this is O(n) squared here. And we also talk about this metric, which is the square metric. So it's the opposite of symmetric. Okay, if this is 1, this must be 0. If this is 0, there must be 1, the corresponding one in the symmetric according to the diagonal. Okay, the values on diagonals are all zeros because that there is no edge pointing to itself. For these values on the diagonals are 0 because the team is not stronger than itself. Okay. Okay, so what have you learned today? So what solution?
We're trying to find the champion.
We are given this directed unweighted graph, okay? And the edge, yeah, which we spent a long time to discussing. There's no edge, but there's an edge, right? Given this metric, if it's 1, there's an edge, okay? In your mind.
No, but it doesn't matter if it's in your mind or not, because the computer still needs to do the same thing.
Yes, okay.
Yeah, but so it doesn't really matter. And if you're imagining it, it's not actually there.
Okay. Okay, so what's the solution?
We find one of the ones in row.
In row, which equals n-1, right?
Yeah.
It's me.
That's it for today. Bye-bye.
Bye. Didn't you say you talk about something?
Okay, bye-bye.